Hello, can you hear me?
Hello, I can hear you.
Okay, so how are you?
Yeah, I'm doing fine. How you doing?
Okay, I am fine, thank you. So basically, I am also busy with my another meeting, so that's why we're not connect the same time. Okay, so now we'll start our today's session, and mainly today I will try to show you that mainly how we can easily calculate the chlorophyll-a concentration using regression equation. How we can easily calculate and then monitor, as well as we also try to discuss about that time series chart, about that how we can easily create the time concentration for a specific time period. So this type of thing I try to complete. Hope you can easily learn. Okay, so let's go. Just I simply share my screen. Okay, can you see my screen?
Not yet. Oh, not yet. It's trying to go. Okay. Sure.
So let's go. So I will show you that all of those things from beginners to advanced level. It's also better. Okay. So okay, I think some networking issue. Okay, so let me open a new code editor. Simply open a new code editor. I hope you already make your code editor. Okay, mainly Art Engine already make. Create. Yeah, can you hear me?
Yeah, I'm hearing you now.
Okay, I
I was
think some networking issue. Yeah, okay. Okay, let me share. Okay. So let's go about that. We try to discuss about them one by one all of those things. So first of all, here you can see it's a code editor. Okay. So using this in this time, this is our code editor. In code editor, we can easily access all of the satellite images. For that, you can see the browse data catalog. Okay, so click on here. Then it will be open all of those image collection for Landsat or Sentinel. You can see. In this time, I want to work suppose Landsat. So click on the Landsat. I simply search on the Landsat, and here you find out the Landsat 9, Landsat 8, Landsat 7. Okay. Suppose I want to use the Landsat 8. So click on the Landsat 8. And further here you can see we can get the surface reflectance and top atmosphere. So basically for the water quality monitoring, it's also better to use the top of atmosphere image collection. It's better to use. Then we can get the very better result. Okay. So in this time, simply click on the top of atmosphere. I want to get this top atmosphere reflectance. So here you can see we can get the dataset availability 2013 to 2014. Okay. So now we can easily use the data and create the image collection between this time period 2013 to 2024, this time period, as well as we can also make the time series chart. Suppose year of 2013 to 2024 annual time series chart we can easily create using this image collection for the chlorophyll concentration. But your main target is that. Okay, can you hear me?
Hello?
Yeah, can you hear me now? Yeah.
Yes.
Okay, a lot of networking issue. I
Yes,
hear
hear
you.
you.
Okay. So here you can see this is our image collection. In this image collection, we can easily access the image from year of 2013 to 2024. Okay, this time period we can easily access this image collection. And here you can see, I simply copy this snippet from here. Simply copy. Okay, simply copy, and then paste on my editor and give a variable name. You can put any name. Suppose I put the variable name is that Landsat. Okay. So now it's my image collection. This image collection I just stored it in a variable. So now this image collection I need to filter. Okay. According to my region of interest, according to my region of filter, emitter, all of those things get in here. I simply search my place. Suppose I work for that lake Victoria. Okay, I want to work with this lake. So now you can say it focus the lake Victoria. In this time, this is my suppose this is the lake. From this lake, I want to observe what is the chlorophyll concentration for this lake. Okay, so for this time I just click on rectangle and select my lake. Suppose it's my study area. It's my study area. I simply select the study area. Okay, and I give the study area name. Suppose RY. Okay, you can put any name. So now this is my image collection. This image collection for whole world. But in this time, I need this image collection for this study area, mainly ROI. I need this image collection for this study area. So for that, I simply use a function. This function called the filter bounds. So just use a function filter bounds. In this time, this function intersecting with my region of interest. So basically it's the ROI. I simply copy and paste here ROI. Okay, and I want to observe the chlorophyll concentration, suppose for 1 year, only for the 1 year. Further, I'll show you that for the 10 years later. In this time, I show you that how we can easily get the 1 year. So here, suppose filter date. The time period, suppose year of 2000, suppose 23. 1st January from year of 2023, December 31. This time period I put it here. And further, I just put here this image, suppose filter metadata. I just take only for this image, which image is the less than 1% cloud cover. So in this time here you can see image properties. I just use here the cloud cover. I simply copy and then paste here. And the operator, suppose I put the operator is that less than 1. So now let's check how many images is available in here. I simply use the print function and call the Landsat and click to the put here the size function. Mainly this size function help you to identify how many images is available. Lot of networking issue, yeah.
Hello?
Yes, can you hear me? Yeah.
Yeah, I'm hearing you.
Okay. Lot of networking issues. So okay, in this time here you can say I can get only for the 1 image. Okay, for this study area I find out only for the 1 image. Okay, so in this time I just simply check about that acquisition time. Suppose I simply print the Landsat. So now we can got only for the acquisition time about this image. So here I can get the image. You can see this image is mainly this time, year of 2023, 29 May. Okay, so in this time I just simply copy this ID from here, copy this ID, and also you can see the cloud cover is a 0.34. Okay, so now I want to display this image. Okay, for displaying this image I just take a variable, suppose image, and now put here ee dot image and put here this ID. So now put here map dot add layer and add this layer of this image. So now click to the run. In this time you can see this image is added in my study area. You can see it added. I want to clip with my shapefile. I want to clip with my boundary. So for that I simply use a function, this function called the clip function. Clip with this ROI. I simply copy the ROI and paste here. So now click to the run. That is only visualized for your study area. So here you can see it show this type of color. So I want to add here, suppose band combination. So click on here, and further I just add here the suppose red band, suppose green band, and also put here that blue band. Okay, and custom stressing 98%, and further apply. So now it shows this type of visualization. Here you can see I can get this type of things is the water body, and it shows the other satellite images. Okay, so now I just click on the import button, just click on the import and copy, and further I simply paste here and I put the layer name, suppose image. In this time here you can see I got my image for this study area. Okay, so in this time from this image I want to extract the water body. Okay, so from this image I just need to extract the water body. So it's a water body, I can easily find out it's a water body, but I want to extract the water body from this image. So this type of things I want to do. Suppose here you can see I already write the code in here for this region. You can see this is the satellite imagery of Landsat. So from here I just extract the image of water. So you can see it's extract the water. Okay, we can get the water body. Okay, so in this time how I can extract the water body from this image? So for that we are just applying this function for watermarks. I simply copy and further I try to use in here. Suppose I just paste. In this time here you can see I just take a function. I put this function variable name is the mndw function and put the element name is the img. I calculated the mndwi. So what is the mndwi? So I simply search on the Google. Suppose mndwi formula. So here you can see this is the mndwi formula. Okay, normalized difference water index. So in this time we calculated that mndwi, and here you can see this formula is the green minus short wave infrared divided by green plus short wave infrared. So in this time we are just applying the same things. Green is that B3 and B6 is the short wave infrared. Okay, here you can see the band number also, band name. B3 is the green and B6 is the short wave infrared. Okay, just I use the B3 and B6 and I use a function normalized difference function. Okay, and when I use this function normalized difference, then it computed B3 minus B6 divided by B3 plus B6. Okay, I put the rename as a mndwi and return, and in this time I take the greater than 0. Okay, so basically all of those positive value indicating the water body for mndwi. You can see we can get the value mndwi range. I simply show you that. Suppose range mndwi value is range from -1 to positive. Okay, and all of those positive value indicating the water body. So for that in this time I just mndwi greater than 0. So it's indicating the water body, all of this water body. Okay, so then further I just simply call my image. This is my image. Simply copy and paste here. Okay, so now this is my function. This function I add with my image and I want to display this water. You can see, click to the run. So now it display the water body from this satellite images. It extract the water body. You can see we can get this type of things. This type of water body we can get from here. Set of color, cyan color, identify about the water body. So now further from this water body I want to extract about that, suppose chlorophyll. Okay, in this time you can simply search on the Google. Suppose NDCI, it's the index formula. I simply search. It's called that. Suppose you can see this is one kind of paper monitoring chlorophyll-a concept in African water bodies. So in this time monitoring chlorophyll-a. So in this time they are used as the Sentinel-2. Okay, and then easily find out the normalized difference chlorophyll index NDCI. Okay, and you can see algal blooms are associated with the presence of chlorophyll-a. Okay, so when I find out the high concentration of chlorophyll, it associates with the algal bloom. Okay, and here you can see the algal blooms are associated with the chlorophyll-a concentration in water bodies, and develop the normalized difference NDCI, which severs the quality of indicator of the concentration of the chlorophyll-a on the surface of the water body. Okay, this index required the information of a specific part of the infrared spectrum known as the red edge. Okay, this is the capture the part. Okay, Sentinel-2 imagery. In this time, it very useful for that concentration of the chlorophyll using Sentinel-2. It's very useful. So this method I also show you that further class. In this time we talk about the Landsat imagery. Okay, and in this time we are using the only for the Landsat image, but further I also take the another session. This session I also try to show you that how we can easily monitor the chlorophyll concentration using Sentinel-2. Basically this band called the red edge. This is the another kind of band. This band also help you to monitor the chlorophyll, and it also very useful for that. Okay, so further I also show you that how we can easily calculate the chlorophyll using the Sentinel-2 satellite imagery. In this time we talk about the Landsat. Okay, for the Landsat, in this time Landsat, there is no band about the red edge. Okay, you can see the, I show you the satellite image band. You can see there is no band about the red edge. But when you click on the Sentinel, we can easily find out the band about the red edge band. You can see, suppose I simply drop atmospheric click on here. Here we can find out a band. You can see red edge. Okay, so it's this band is very important for that red edge. Okay, for the identify of the chlorophyll concentration, this red edge band is very helpful. Okay, we can easily monitor what's the water condition on the chlorophyll using the red edge band. So this process I show you the further class. In this time we talk about the Landsat imagery. For the Landsat, what we can do? For the Landsat, in this time we can use this type of regression equation. You can see regression equation for water quality model for the Sentinel-2 as well also Landsat. Okay, so in this time here you can see there apply the different types of regression equation, such as you can see the one kind of, it's a Landsat 8, and we can get the chlorophyll-a concentration. This is the equation about the regression equation. Okay, we can easily use this equation and then identify that the chlorophyll concentration, and what is the R square value for that? We can get the 0.67. Okay, this is the regression value about that. So in this time, so this is the formula. Okay, so this formula I want to apply on my code, and then further I want to extract the chlorophyll from here. So I simply here this formula, it's a chlorophyll-a equal this formula. Okay, so this is our formula for Landsat. So in this time you can see this formula mainly 15.717, and also this B2 multiplied with the B2, then 192.236. Okay, so it's one kind of formula. So this formula I just connect with my water body pixel and then find out what's the condition of chlorophyll-a. Okay, and further we also next class I'll try to show you this method monitoring the chlorophyll-a using the Sentinel. Okay, it's also very useful for identify the algal bloom as well as also chlorophyll concentration. You can easily do it associated with that. So in this way, we talk about the Landsat. So now what can I do in this time? We are just, suppose I simply copy the same code. I already write the code in here. Copy, and then okay, simply copy from here. Okay, so now this is the formula. I just create another function. Suppose I put the function and put the function variable name, suppose chlorophyll. Okay, chlorophyll-a. I put the element name of image, and then further I put the curly bracket. In this curly bracket, I just put my equation. Okay, you can see this is my equation. Okay, I think it's another equation. I simply check the equation. It's a 15 point. Okay, this is the equation about that. So in this time I use the same equation. Okay, so in my code. So for that, what can I do? I just simply copy this equation from here and use this equation in here. I simply remove this previous equation. Paste. There you can see I simply call a function and then put the function variable name is the chlorophyll. Okay, then put the image, and further I simply take a variable chlorophyll. I put this element name image, put the expression, and then put my expression is that this is my equation 15.717 plus negative this value, then B2, okay, then B3 and B4. Okay, in this time we have to define about that what is the B2. Basically B2 is the select the B2 band, B3 is select the B3 band, and finally B4 select the B4 band. In this time B5 not need. I should remove that. It's not need. Remove that. Okay. And further here you can see I just put the rename as a chlorophyll. I return this image as a bands of chlorophyll. Okay. Further I want to display this result. So just I simply click the run. In this time it print this image chlorophyll. Here you can see. Just click on here and check the bands about that. In this time it added the new band. It's this band called the chlorophyll. Okay. So in this time it create the another new band. It's called the chlorophyll. So now I want to visualize this band. Okay. For visualizing this band, we are just add suppose map.add layer and call this image chlorophyll. Simply copy and paste and click the run. We can get this type of result. And further, I just simply click on here. See? Okay. And now we are just use the select function and put the band name. Suppose my band is that chlorophyll. So just simply copy the chlorophyll and paste here. Okay. So now click run again. So now click the layer 3 and I want to custom is stress 98%. Further apply. And okay, we add the color plated. Okay, I think we have to use the another equation. It's not more better. So for that in this time, suppose let me check the equation from here. So chlorophyll chlorophyll equation, but this equation is only for the Sentinel-2 satellite imagery. Okay, it's a chlorophyll equation. Chlorophyll equation it's used for that Sentinel-2. Okay, you can see this we also get the better accuracy 75 R square value, and also you can see about that Landsat. For the Landsat we have to use this type of equation. And so let me try and check the result from here. I add the color plated. Suppose click on here. That put in here I simply put the color plated. Suppose I put here this type of blue color for the low concentration. Then suppose green color. Suppose then put here the yellow color. Then put here the red color. Okay, then further apply. Now we can get this type of map, the reflectance of that chlorophyll. In this time we can get suppose this type of color about red color identify about the high chlorophyll concentration, and this type of blue identify about the low concentration. Okay, so this type of pixel actually it's a 30-meter pixel area, so that's how we can get this type of result from here. So here you can see this type of pixel, red color pixel identify about the high concentration of algal bloom as well as chlorophyll. Okay, and this type of pixel mainly blue color pixel identify about that low concentration of algal bloom. Okay, you can see this type of green color is the medium concentration of the algal bloom. Okay, so in this time we can get the find out the maximum. We can get the high concentration of chlorophyll for this lake water. So basically this type of color, blue color identify about that low concentration of that algal bloom or chlorophyll. But this type of yellow color or red color, this type of green color identify about the high concentration of the algal bloom for this lake. Okay. In this time, suppose I want to I just use this code, same code I want to use for that, suppose Sentinel. Okay, then we also get the more better result. For the Sentinel, suppose I just make a new code editor again. I take a new code editor and try to develop this code using the Sentinel imagery. Okay, because you can see we can also calculate this type of chlorophyll also using the Sentinel image collection. Okay, we also put the Sentinel image collection. We can easily do it, no problem. So now in this time, I just simply imported the image collection, or I simply copy the same code from here and then use it. It also better. Suppose.
Hello?
Can you hear me?
Yes, we are not using Sentinel, right?
Yeah. In this time, it's the Landsat. Okay, in this time, I show you that same code we try to develop using the Sentinel. Then check the difference about the two result. Okay, so I just simply copy the same code. I simply change the image collection, another parameter, but all of those things will be same. You can see. Suppose here you can see the Sentinel in the Sentinel image collection. I simply copy it, copy this, and then also change it. This image collection. Okay. I also need to simply search here my study area. Suppose lake. Yeah. Simply search.
But Sentinel is limited to, it doesn't cover 2000 up to 2005 or 2010.
Yes. For the big period, we also use the time series chart for that Landsat.
What about Modis?
Modis is also provide the high, not much better resolution, because Modis is also more pixel area is more. Okay, so for that, for this type of a small region, suppose this region is not much big. Okay, so when you want to use the Modis in the small region, then we are not get the better result. But when you want to apply the Modis in the big region, such as the ocean, okay, as a big water body, okay, as a sea, you want to monitor the algal bloom, then it's also okay. But for this small region, you can see it's a small region. This type of region, when you apply the Modis, then we will not get the better result, because Modis pixel area is big, okay, very long pixel area. So that's why in this time, for the small lake or a small river, we did not get the better result using the Modis. So that's why it's better to use the Landsat or Sentinel, because this pixel area is lower than Modis. Okay. So in this time, I show the result from the Modis and then check what happened. Suppose I put the same time period, filter bounds with my study area, mainly it's a ROI, and further I change the filter metadata. In this time, I simply change it and try to find out from here. You can see the image properties, copy the cloud pixel percentage and paste here. Okay, less than 1% I take, and further I simply comment these things also comment these things, and full code I simply commenting. Okay, so now I just try to check how many images. I also change the variable name. Suppose it's a Sentinel. You can put any name as a variable, Sentinel. So now I just print this Sentinel, simply copy and paste here and click the run. Okay, so it's working. Okay, in this time we can say how many images we can get. We can get the 13 images, okay, for this region. Okay, so now I want to create the median composite using total 13 images. So just put here the median, and it's clip with my study area. Suppose clip with my study area, which is RY. So now I display the layer. Okay, a map dot add layer. So just I simply put a function map dot add layer, and further call the Sentinel and then click the run. In this time we can get the Sentinel image collection for year of 2023. It create the median composite. Okay, and you can see we can get this type of color, mainly it's a totally black color. So I simply click on here and further I set the band combination. Suppose I put here the red and blue. Okay, and further customized is 98%. Okay, then apply it. So now we can get the very better image than Landsat. You can see we can get the more better image in this time because this pixel area is lower than Landsat. Okay, in this time it's a 10-meter resolution about that image, 10-meter resolution, but Landsat is the 30-meter and Modis is 500-meter or 1 kilometer. So that's why when you want to use the Modis, we don't get the better result for water extraction for the small lake or a small river or a small pond. We did not get the better result. So that's why it's also better to use Landsat or Sentinel. It's also okay. There is no problem. So in this time here, you can see I simply, okay, then I also need to import that thing. So click on here and also custom 98%. And also import, apply things and also import. Okay, so now simply copy and further I paste here and give the suppose it's a imagery or image. Okay, so now I can get my image. Okay, so now from this image I just extract the water body. Okay, I just use the same, suppose I just create a function. So this is the function. I simply use the same function to extract the water body. Just I need to change the band name. In this time you can say I want to apply the MNDWI. Okay, and what is the formula about the MNDWI? I simply search on the Google, then we can easily get the MNDWI formula for Sentinel-2. Here you can see we can call I simply open these things, or I simply open these things. Here you can see we can get the water bodies mapping from Sentinel-2 imagery using the modified normalized difference water index at 10-meter resolution, mainly 10-meter pixel area. Okay, very high resolution about that. So in this time, I just try to find out from here what's the formula about that using here. So it's not, here you can see, it's not, okay, you can see here, green minus, okay, MNWI. Green minus shortwave infrared. Okay, green minus shortwave infrared. This is the formula about the MNDWI. Green minus shortwave infrared. So here you can see for the Sentinel, you can check the band about that. You can see green. So we can get the green is the B3 and shortwave infrared is the B11. So B3 and B11. So just I put here that B3 and B11. So B3 and B11. Okay, B11. So further I extract the greater than 0, all of those water pixel, and further I want to show the result. So now click the run. In this time it extract the water body. Oh, I need to change also in here. So in this time I simply call my image Sentinel. I simply copy the Sentinel and paste here. Just connect this function. So now check the result. You can see what happened. You can get. In this time it extract the water body. You can see. Okay, and in this time this water body extraction from 10-meter resolution. Okay, pixel area is the 10-meter, very higher. But first time when I want to use the Landsat, where is the Landsat? Yes, Landsat, this water would extract the information from 30-meter pixel area. But in this time we take the water body from 10-meter resolution. Okay, very high resolution. We can extract the water body map. You can see it's our water body. Okay. So now I just use the water body and then further I want to calculate this equation. Here you can see already provide the equation for Sentinel. This is the equation. I just put the equation and further check about the chlorophyll-a concentration. So I simply copy. Since the equation in here, suppose I simply remove this code from here. First, here's the equation. So this is my equation. I simply copy and then I just change it. Suppose I simply change it. Okay. So in this time, I need to define what is the B2, what is the B3. Okay, I need to define it. So mainly in this time, I define one by one. Okay. So B2 is the B2 band. Okay. Then also you can see the B3 is the B3 band. Also you can see the B4 is the B4 band. And also at the another band, it's called the B5. So I simply copy and paste here. Just it's a B5 band. Okay, B5. Just I put this all of this equation variable I define one by one I put in here. So further we are just rename it the chlorophyll and return this band to the chlorophyll. So now I just simply click to the run. You can see it added the chlorophyll map. I'll also show the chlorophyll map in here. Okay, we can get this type of gray color, but we can easily change the color and get the better map about this. Suppose I just click on here. That I just simply stressing custom 98%. And then apply. And also the color. Suppose for the low cons, I simply use this type of color. For this high, this type of green. Greater than I show this type of yellow color. Greater than yellow, I simply show as the suppose red color. Okay. Then further apply. In this time here you can see we also get the more better result than Landsat imagery. In this time, this pixel is look more better than Landsat imagery. When I apply this equation, we can easily identify this type of red color is identify about the. Okay, I just simply open this map. Right. In this time, this type of red color identify high concentration of the chlorophyll. Okay, and also you can see this type of yellow color also high. Okay, this color identify about the high concentration about that. Also you can see the yellow color is high concentration about that. So basically in the river bank, okay, river bank water have the more concentration of the chlorophyll. River bank about that you can see river bank or lake bank, we can get the more concentration of chlorophyll. Okay, and this type of blue color identify about the low concentration of the chlorophyll. It's the one kind of method. Just we are applying this type of formula. And if you want, you can also use this method. Suppose chlorophyll A concentration, it's called the NDCI. Okay, it's the normalized difference chlorophyll index. So here you can see, basically in this time, we are just calculating the normalized difference index using a NDCI model. So just I show you this example, then it's better. It's also more useful to identify about that chlorophyll and algal bloom on the surface water. It's more useful. So for that, I simply open a new code editor to show you these things. Suppose just open a new code editor. And further, I just try to find out my code. It's called the NDCI, normalized difference chlorophyll index we are use. And then further, we can find out that chlorophyll and algal bloom is associated with the chlorophyll concentration. So just I try to open this code. Okay. So in this time, you can see we are using the Sentinel surface reflectance imagery. Okay. So for that, I simply show you the result first and try to show you this result for other water body. So you can see it extract the water body from this lake from here. And then further, where the high concentration of chlorophyll, it's called the more polluted water. We consider while we find out the high concentration of chlorophyll is considered as a more polluted water. Okay, because it's a high concentration of the chlorophyll, and also low, it's the normal. Okay, so in this time I try to apply this code in your study area. Suppose I simply search here Lake Victoria. Suppose this is my study area. I simply remove that things from here. And further, I just draw my study area. Suppose it's my study area. I simply draw it. So now just I put this name is the RY. Y. And now click to the one. Then this time it show this type of feature, and it extract the water body from the whole area. We have to change it something because we have to change it. In this time we are extracting the water body and just put here that greater than 0. Okay. And we also put at the NDWI, not MNDWI. NDWI is the another water index. It's not modified. Okay. So now try to check again. Okay. So now I can get this result, this type of things. So just I close it, and further here I can see we're just increasing this part. Suppose I just simply increasing, and then just find out the stressing 98%. Apply. Okay, you can see this is the condition about this lake. There are a lot of algal bloom as well as also mainly chlorophyll concentration, high concentration. Okay, you can see this type of red color identify about that. So if you want to check the pixel value, suppose in this time it's we are just applying this method. Okay, so you can see I will share you this paper also. You can also read it. It's more powerful and it's very useful, and it's only possible to calculate the normalized difference index in the Sentinel-2 satellite imagery, because Sentinel-2 satellite imagery have a band. It's called the red edge. Okay, red edge band is only available for the Sentinel-2 satellite imagery. So that's why this red edge band is more reflected the chlorophyll. Okay, so that's why I also get the better code when I use it, and I can easily identify what is the condition about this water on the lake. You can see here, simply click on here, and I simply click on here. You can see what is the value about that NDCI. We can get the 0.2, mainly positive value, high positive value identify for the high concentration of the chlorophyll. Okay, suppose I click on the any kind of, suppose this what I simply click on here. Here you can see we can get the low value. We get the negative value. Okay, so basically this type of negative value, negative pixel identify about that low concentration of chlorophyll. There is no chlorophyll. Suppose we find out this water. I have to zoom it. Suppose you can see this water in year of 2021. I check it. There is no chlorophyll. We can get it's a totally negative value. You can see it show that negative value. But when I check about this type of water body, you can see, suppose click on here, we can get the high concentration of the chlorophyll in the water body, 0.3. It's the high concentration about the water body. Also, you can see about that other region. Suppose you can see this is another water body. Suppose click on here, we can get the negative result. Okay, because there is no concentration of the chlorophyll. And when I get this type of red color, it's identify about the low, high concentration of the chlorophyll. Simply click on here, we can get the high concentration of the chlorophyll. You can see 0.4. Okay, and this chlorophyll is also associated with the algal bloom. Okay, then from here we can easily find out the algal bloom. Okay, so basically you can see in this time I think this we can get the better result using the Sentinel-2 and put this method. Okay, NDCI, normalized difference chlorophyll index, using the red edge band. Okay, in this time this formula you can see we can use this type of same formula that I try to put in here. We are just make the normalized difference using the band 5 and band 4. Band 5 is the red edge band and band 4 is the red band. Okay, just calculate the red edge band and red band. You can see the band from here. You can see band 5 is the red edge band. Okay, red edge band. It's very helpful to monitor the water pixel and identify the chlorophyll. Okay, so you can see in this table also get the more better result than other method also. But this we can observe the data from chlorophyll from year of 2015 to present time. It will start from the, you can see this time period is that 2015 to 2024. This time period we can observe what is the condition, as well as we also make the time series chart about that. Okay, and further when you want to use the Landsat, then we also get the time series chart from the year of 2010 to 2024, no problem, or 2000 to 2024 we can easily get it because satellite image is available. But there this accuracy is not good than Sentinel, because Sentinel, we can easily get the more powerful or more accurate result we can easily get in here. Okay, so basically this is the three method I show you that. Two method for that Landsat imagery. We are usually put this type of regression equation. Okay, and then we can easily compute the water quality monitoring, mainly chlorophyll. And we also put here the NDCI using the Sentinel-2 satellite imagery, and then monitor the water body about that. As well as Sentinel will also apply the equation. Yeah, please.
So how do we export
Okay, okay.
the picture we already got?
Okay, suppose this is my map. This map I want to export, and further I want to work with the other software such as ArcMap. Further, I just make a curly bracket start, and also curly bracket in, and then further we are just put here the image. First of all, what is my image? So I want to find out my image. So here you can see my image is that mainly this is my image. I simply copy from here and paste here. Description, you can put anything as a description. I put the description, suppose say profile. Okay. Folder. We can put any folder name, suppose water quality. File name previous not need, remove that. Dimension not need, remove that. Region not need, remove that. Region is need. Region is your boundary. Mainly our boundary is the RY. Scale is the resolution. Mainly it's a 10-meter resolution. Other I simply it's not need. Remove that. Okay, so let me check. It's a RY. Okay, lowercase RY. Okay, we have to use the same lowercase RY, and now click to run. So in this time, we can say our task tab will be running, and now from this task tab, we can easily export this map. Suppose click to the run. Yes, so now it export as a TIFF format, and further we can easily work with ArcMap or QGIS software for creating the map. I think I also give you the another session. One session is not complete all of those things, so I also put you the another session for the time series chart. Okay, how we can easily make the time series chart for the water quality parameter from using this data set as well as the Landsat data set or Sentinel data set. All of those things I will try to show you one by one. Suppose how we can easily make the time series chart. Okay, so in this time I also send you this type of code. You can see it will be working. Okay, so in this time I also send you this code. You also try to practice all of those code I send you for water quality. And further, I also put the another session, show you that how we can easily make the time series chart for the different time period. Okay, so in this time, suppose I just click to the open in drive, and then you can easily download this keep image. As you can see, this is our map. I simply download it. Open A. Okay, download it. And you can I simply work with the ArcMap or QGIS software for preparing the map. It's very easy. Suppose I show you that, suppose QGIS. Or you can also do the ArcMap also, no problem. So just open that. Okay. Good evening. So just I simply open this tip image.
Hello, I can hear you again.
Okay.
Hello?
Yeah. Okay. Let me check.
I can't hear you. Hello?
Hello. 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 Can you hear me? Hello.
Hello?
Yeah. Can you hear me? Yeah.
Yes, I can hear you.
Okay. Okay. I think some networking issue. Let me check. So let me share my screen again. You can see here, I already imported these things in my ArcMap software. So here I can get this type of map. Okay. So
Which
now,
software are you using? QGIS?
yes, you can also do for the ArcMap, no problem. Okay.
I downloaded QGIS. I think I just downloaded it today. I will learn how to use it.
Do you have ArcMap software?
Sorry?
You have ArcMaps or ArcGIS software is available for you.
No, I don't have. I tried accessing it, but then it's like I have to pay for it or I have to like buy it. It's not free.
Okay, if you want, you can also use the Crack software from here, no problem. As the ArcMap software is available for the Crack software, and you can
Yeah,
yes, yeah.
if I could get that, that would be okay. I can get a crap software for that. But which one is more preferable to work with? The QGIS or the ISAC server?
Well, I use the both of things. Okay, ArcMap or QGIS, both of things I use. So that's why more two things is the more better. No problem. You can use the ArcMap or QGIS. No problem. Of color. or any color combination you can easily put, no problem. This time you can see that I think it was more better. In this tab, this white can identify about the low concentration about that chlorophyll, and this type of green color identify about the high concentration of the chlorophyll. Okay, this type of green color is the high concentration of the chlorophyll. Or you can use any color, no problem. Here you can see that a lot of color setting easily put here. Also, you can color, and there's a lot of color things you can easily put in here. Okay, I put so this color and apply, and okay. So now you can get this type of things. So this type of green light is identified with the high concentration of the chlorophyll, and it's a low concentration about the chlorophyll. Did I get from here? Or you can put it this here, suppose apply and okay. So now it will be more better. You can see red color identify about the high concentration of the chlorophyll. Okay. Blue is identified about the low concentration of the chlorophyll. Put here this map for that view. And okay, it's okay. So further, you are just make a layout. The layout. So first of all, simply go to the project, and here you can see the layout option. Where is the new print layout? Yeah.
Layout manager on there.
Layout, yeah. It's a print layout. Okay, clear on hand. And I put the name, suppose MDCI, and then click to the OK. So now it's create this type of layout. Okay, in this time I just simply add all of those things one by one. Suppose add the map, legend, all of those I do add in here. After doing these things, we try to add the layout. And you can double click on here, you can see the page properties. Okay, just right click, we can get the page properties. From here you can see if you want, you need the A4 size page or any page, you can simply select the different format page you can easily get from here. Okay, So A4, you can select anyone. Suppose I simply here the suppose A4. I simply select, or also you can say the custom. Anyone can simply select. Suppose I set that A4. Okay. As well as we can also get that landscape or portrait. Anyone can use. Suppose portrait, we can get this landscape. We can get this of things. Okay, which one is better for you? We can simply select it. Basically, it's depend on the map size or map presentation. Anyone, we can easily put it. No problem. So now further we are add this type of thing. Suppose we are adding the map. So for that adding the map, we are just add the map setting. Against the add item option. So just I simply background different types of color, or if you want to simply put the same things, no problem. And further simply apply to all pages. And you can see the add item, add map, add 3D map, add picture, so add level, so add map. Okay, then simply drag and paste this type of thing, simply paste in here. So I want to put all of this in the one layer. Just simply paste. Okay, now rendering this map, you can see, because in this time we also added the satellite image also. Okay, we can get this type of map. Okay, so now further we will say add here that item, and here you can see the add legend. Okay, so click on the add legend button, and I want to add legend. Suppose I want to add the legend in here. Okay, so then further we will just put here. So you can simply click on here. You can see the item properties, and from here you also put the title, or also map one legend, or different types of still for the legend can do it from here. Okay, so in this time you can see that the lot of item background. Suppose uncheck the background, then this background is the remove. Okay, so I think background is the more better, because you can see the background. And if you want, you can also change the color about the background, and also you can see the rotation, position. There's a lot of things we can do from here. Okay, as well as frame, we can also put the frame. Background, we also put the background. And also you can see about that your title about your thing. Suppose legend item, we can get those things. Here you can see the Google satellite. Suppose I remove this Google satellite, so for that I just simply click on here, and then further remove it. Suppose how I remove that, put the title. Suppose I put the title is that chlorophyll. Suppose chlorophyll concentration, or you can put any name as a title. Right? Suppose if you want to put the NDCI, any title is your map title, simply put here. Suppose I put the chlorophyll. Suppose it's a CSO. I put the chlorophyll. And then further we are also put here the different types of style, right, left, I think the left is the better. And then for the legend item, we can get the auto update. Okay, it's automatic update when I click on here. Only show item inside the linked map. Okay, it also okay, no problem. Font and text formatting. So click on here. In this time we also put the font or text formatting. Suppose different types of style for the formation about that. Also you can columns about that, equal interval or speed layer. So equal interval, different types of style can do it. Suppose spacing, position and size. You can also put at the position. Also you can see the position. You can increase the position from here. Okay, you can see the X position, Y position. We can easily up and down easily do it. This map. Suppose I just put it in the lower part. Put the lower part. So put here this side. I just put in the side. And further we also increase the height about that. You can increase the height. As well as also you can see the background. If you want to also put the frame. Okay. You can see the click on the background. It will also the background. Or if you want, you can also change the background color. Different types of color you can put in here. Suppose I use this color, no problem. And further, okay, as well as there's a lot of style you can also check later. In the sample, you can see the sample. So different types of sample you can also add in the legend item. And also the item ID. Here you can find out the rendering, blending, normal. Okay, opacity is okay, no problem. And okay, and suppose click the another item. Okay, it's okay. So we are considering these things. And then for that add item, here you can see about that the marker, add marker, or if you want you can also add here the level, add picture. So scale bar, simply add the click on the scale bar. I want to add the scale bar suppose in here. Let's put this scale. Okay, this is my scale about this map. Or you also put here the different types of style about the scale. You can see kilometer or feet. You can put anything, no problem. So I put the kilometer. Suppose in here. It's my scale. And further add the item. Here you can see about that add level. Level means name. We can easily add north arrow. Suppose I put the north arrow in here. Arrow. And you can see different types of shape. We can easily add the north arrow. Different types of symbol we can easily put in here. And also put the color, change the color. Suppose I put the color, this type of color I put in here as a north arrow. I put it in here. Or just in here. Okay. And for that, I just simply click on the add item. And I want to add the suppose add a level. I simply add a level. So add a level. I put this as a title in here. I put the title. Suppose map title. I put the title. It's a fluoro concentration map. Suppose 2023. I put this time. And further, we also put here this increase the. I put the in the horizontal or vertical. Anyone suppose font. You can also different types of label font. Also styling about that. Also you can see the frame. If you want, you can also put the frame about that. Also put the background about this title. Okay? As well as you can also do for that different types of items. Suppose click on item ID and rendering. There's a lot of option we can easily do it. Suppose font, rectangle or buffer, x size, y size. We can easily do it. We can increase that. I think it's not need. So I want to increase the font size. Suppose okay, it's okay, and I also change the font color. Suppose it also better to use the white color. There's option I use it. It's not better. This it's not better. Use there suppose gray color. It's not better. So I want to use the color suppose white color. Okay, perfect. I think yeah, white color. We choose. And if you want, you can also add the more style. And finally, you are just exporting this. Yeah, can you hear me?
Yes. What about changing the entire image background, like the remove auto grain and stuff? Like
This one, you want to remove this background.
yeah, those background like the image shouldn't appear white. I mean, it shouldn't appear on a white background. It shouldn't have
Okay,
all
okay,
these.
let me save it, then I'll show you that. Suppose I simply export this image as an image. I simply click on here. And further, I want to save it in my desktop, suppose in my download folder in DCI and save it. And you can see 300 dpi and then save it. So now it will saving. You can see it will be working.
And then another thing, where can I find the georeferencing number?
It already georeferencing. Okay.
It's already.
Yeah, you already done the georeferencing because in Google Earth Engine platform, when you download any image or any shape file, it all automatically georeferencing. So that's why we are not concerned about the georeferencing. It already done. Okay. So in this time, suppose you want to remove this type of background, we just put the white color background. So for that, we are just suppose I remove that. In this time, we will uncheck it. Okay, uncheck. and do for the same things. Suppose simply click on here and go to the print a new layout. I put the name about that, suppose ND CI, and then OK. And further, in this time, simply click on here and go to the page properties, and I select the A4 size page. Okay, and suppose I put the landscape. Okay, then simply increase that, and here you can see the add item. So just keep in that. So go to the below. Four. And apply to all pages. I simply pull, and you can see the add item. So just simply add this map without. I simply select that. In this time, it select only for this map. We had so now we can add all of those other things. Okay, just simply uncheck the satellite. Then we are just add the legend or other things. Suppose I add the legend. So add legend. Just I put in here this legend. Okay. So now we can get only for the white color background, and you can save it as an image or PDF file and represent it. Okay. So basically this is the process, and after that when you want to show this image again, suppose I already stored it in here. Suppose this is my final map I create from here. So you can see we can create this map of the chlorophyll concentration. Okay, we can get this type of map. Okay, and this is the legend, this title or not, we can easily get this type of things. Okay, so it's a high concentration show this type of color, and low concentration show this type of blue color. So basically this is the process for creating this map in Google Earth Engine, and download the TIFF format and use it in ArcMap or QGIS software for creating this type of map. Okay, so you also try. I also send you for today's decorate class. I also send you the practice code, all of those which I show you. You also try, and further face any problem, then let me know. I also guide you. And next session, I will show you that how we can easily make the time series chart for the different interval, different time period, how we can clear the time series chart. Okay.
Okay.
Okay. So today's number. Okay, you try and practice. Okay. Thank you for joining. Okay. Have a good.
So
Yeah.
you're gonna send me those code?
Yeah, I also send you the code link also in your WhatsApp. You can easily get it. No problem. Okay.
You can just send it to my email, my Gmail, please.
Okay, you can send me the Gmail. I also send you. No problem.
Yeah, I'll send it to you.
Okay, thank you for joining. Okay, have a good night. Okay, bye. Okay, bye.